Good afternoon, everyone. Thank you for being here at the first training session of the GeoField convening. So I am here to introduce Rocio Carrero. She is a manager of education and research at Planet Labs, and today she is going to talk to us about the Planet platform and go through some of that data. Her background is in environmental science, and she has over a decade of experience in the geospatial field. So, Rocio, go ahead.
Thank you so much, Carly. Hi, everyone, and thank you, Ariel. I am so very honored to be here. I wish I was in person, but I still very happy I can make it thanks to tech. I hope everyone can hear me well, and I'm going to start sharing my screen so we can start the training straight away. Wonderful. Okay, perfect. So let's get this started. Today I'm going to be presenting the first session of the trainings. It's going to be a Planet Labs data training. And for the sake of logistics and because of Zoom, instead of doing a live demo of the data, the platform, I have a presentation, but it's basically the same that you will see if you open the platform yourselves. You can actually follow me with our platform if you wish. So today I'm going to be covering a brief introduction of myself and Planet. And then we will explore high and medium resolution Planet satellites and products. We will make a walkthrough explorer, which is our database. And then I'll showcase a few applications examples, which is, I think, the most critical part. And of course, at the end, we have some time for questions and answers. I will kindly ask you that if you have questions, please keep them to the end if you're so very kind, because or interrupt me talking, but please don't write in the chat because I'm really unable to read and present. I find I have that limitation. So just interrupt me talking or please wait for the end. I really appreciate it. So as Carly kindly said, my name is Rocio Carrero. I am the Customer Success Manager for Education and Research at Planet Labs. I have a beautiful position where I get to work with many universities and research centers who work with satellite data and remote sensing. And my job is to leverage the data that Planet has and help these researchers to utilize it in the way they want. So I have the fortune to work with College of William and Mary, and I'm extremely honored that they invited me here today. My background is in environmental sciences. I worked on the development and adoption of geospatial tools for climate change adaptation and disaster risk reduction. So I feel personally, as I said, honored and also very happy that GeoField organized this sort of convening, which is so very critical for the current times. So Planet is a space and data company, and its mission is to image the world every day, making change visible, accessible, and actionable. To do that, Planet has a constellation of hundreds of satellites that are right now flying over us. And with this constellation of satellites, they can capture images of any point of the Earth, such as this beautiful images that I'm going to show you today. This is the Niger River in Mali, and you can see very beautiful delta formations that are really breathtaking. We can also observe change, like here in Lake Chad, with the rainfall comes, how it heavily transformed the landscape. You can, of course, have a time series. You could also, and really critically, monitor human action and intervention, as in this case in Obineven in Ghana, when there is artisanal mining going on, and in a a space of a few months, it's changing the landscape really dramatically. And you can also perform a spectral analysis on planet imagery to be able to see, like in this case here in Guwahati, India, how the melting of snow and the abundance of water change the landscape and provide a lot of water availability for the crops in the area. Okay, so with these examples, we are going to start the overview of our satellites and products. As I said at the beginning, I'm going to focus on medium and high resolution today. Planet has other products and actually is launching new products this year. But today I'm going to cover those two, medium and high resolution. I'm happy to perhaps touch base in the other things when we have the panel discussion on Thursday. So the first satellite I want to show you is our DAP satellite. This is the signature satellite because this is how Planet started. This satellite that you see here has the size of a toaster. It's really incredible how something so small can be so powerful. And they were launched in 2013. Right now, there are over 200 of them. They capture 3.7 meter resolution imagery, and they can cover 4 to 8 spectral bands depending on the generation, because each generation of these DAP satellites have more and more capabilities. Here on the right, you can see an image taken by one of the DAP satellites. This is a comparison between Sentinel-2 spectral bands and the different DAP satellites. The first one, DAP Classic, in 2017 could capture 4 spectral bands. The second generation could capture 4 bands, but much more sharp and defined. And the current generation of DAPs, they're called super DAPs, and they can capture 8 very well-defined spectral bands, with a concentration on some spectral bands that are particularly useful for vegetation and crop studies, such as yellow or other types of green. PlanetScope is the name of all the DAP satellites combined together. Together, they're like a flock of birds who fly over the Earth continuously, and that allows to take nearly daily imagery and capture the whole Earth landmass. It does not cover the oceans, so I want to clarify that. It covers the landmass. We have an archive back to 2014, and I think that's one of the biggest strengths of this product, that you would have daily data of a specific area from 2014 until now. Well, SkySat is our high-resolution satellite. You can see here a model of the satellite. It's a bit bigger than DAF, the size of around a fridge, kind of. We have over 20 of them, and they were launched in 2013, and they can capture images of 50 centimeters resolution, which allows a definition as the one you can see in the picture here on the right. In terms of spectral bands, it covers RGB, panchromatic, and near infrared. Planet tasking is the name that we give to the fact that you can send on demand SkySat satellites over your area of interest. SkySat, the high resolution satellites, do not cover the whole Earth continuously as the medium resolution does. The high resolution satellite will go to a specific location because of the demand of a customer, take an image, and come back. There is a system that is automated, very transparent, where the customer can actually manage these orders, and they can send the satellites over the desired areas. And we have as well an historical data archive for SkySat with over 10 million square kilometers. They, again, do not cover the whole planet, but they cover the areas that had been in the past tasked by different customers. This is a quick comparison of the two products I just presented, and just the two things that I think that are more relevant is that the resolution of the medium satellite is 3.7. The high resolution is around 0.5 meter. And the spectral bands, medium resolution, we have 8. High resolution, we have this 5. Okay, I'm gonna continue now with the demo, unless anyone has a pressing question. Okay, let's start that a little demo with Planet Explorer. Planet Explorer is a platform where anyone can visualize the data that Planet has, but also download that data into your computer. It's very intuitive, and today I think that this could be the easiest entryway to Planet data. Really, anyone, whether you have no background in remote sensing or you're an expert, can use Planet Explorer. I hope that after today, people feel comfortable to start to use it or play around it. This is how it looks like. It's looks similar to other platforms that are out there, and you have a menu on the left with different options and a little tools menu on the right. Again, pretty intuitive. Here on top, you will have a bar where you can search for a location, and you'll just type the area of interest. For the sake of this exercise, today I'm going to focus on Chabelle, which is a region in Ethiopia, close to the border with Somalia. I would have type here Chabelle, and the explorer will bring me down here, and then you can define an area of interest, drawing your area of interest or uploading a shapefile or in any other format, a special format that you have maybe already in your computer. In this case, the area of interest is almost 7,000 square kilometers. Sorry. Then we can zoom in a little bit. And after that, if we go to the left, we can select the imagery type. As you can see, we can click here, PlanetScope, the medium resolution. And after that, we can also apply some filters. In this case, I love to see at least 80% to 100% of coverage of the area, and having a maximum of 15% cloud cover. I want to emphasize this. Our imagery, the products I just presented, they do not pass over clouds. So clouds are a real issue. Areas that have a lot of clouds, especially tropical areas, although there is a daily capture of imagery, you might not see daily imagery available because they might be covered by clouds. You can still get the data, Planet will give it to you, but you won't be able to see much. So this is something to take into account when you're thinking about applying this type of data for different regions. The availability varies according to the cloud coverage. So I set the threshold to 15%, and you can also change other parameters if you wish. After that, you will be immediately presented with a list of images that meet your criteria. You can see that we have a daily measure in this case, September 3rd, September 2nd, September the 1st, and after that, there is a small jump up to August 26th. Here in this timeline as well, you can see the availability of imagery with that criteria over the month of interest. If you select a specific date, as September 3rd, you will see a preview of that image. we're going to change the dates to see the seasonal changes in the area. This is September. It's a bit drier. This is March 30. It's greener, as you can observe. This is May 28th, when it's much more greener, and also there is much more water. There was a flooding in this area mid-May this year. So there is definitely a noticeable difference in the vegetation coverage. And this last one will be June 25, when the greenery is starting to calm down. If you were interested in downloading any of these dates, you would just have to press here the little shopping cart sign, and you will order. And immediately after that, you could choose whether you want to order with 4 or 8 spectral bands, and you will just receive it in your email and just open the image in your PC. In Explorer, something that I find very useful is the option to have a comparison glider. You can compare different images for different dates or different types in this glider. And here we can see next to each other the area in September 3rd and May 28th, and how this very visible change in vegetation cover is happening. You could also compare a public image, because you can also access Landsat and Sentinel-2 data from Planet Explorer. So you could compare an image of Sentinel-2, say that you are interested to see how it looks like in comparison with a planet for the same date, next to a planet image. Another option that you have in Explorer is to create a video with a historical data set that you choose. In this case, we can create a short video from March to September 2023 in the same area that I've been just showing. And I hope you can see this. It will look something like this, an animated TIFF. You can insert this in presentations or social media or any live work, and many researchers use it for to add some color to a narrative or to a story that they are presenting to the general public. Something else that we can do with Explorer, and I think this is particularly useful in the context of impact evaluation and anything related to crops health and vegetation as well, and water availability, is that we have the capability to perform a spectral bands analysis on the fly. You can do it on the fly on Explorer. You can also do it via API on your PC. I'm going to show you today a few examples so you get an idea of what you can see, but it's something that I feel very excited about every time we do it. This is an NDVI analysis, and these are the 2 dates that I've been presenting, September 3rd and May 28th. It's very clear how much easier it is to see the vegetation changes in terms of humidity with the spectral bands versus a visual image. And here, this is an infrared analysis. And same thing, we can see clearly how on May 28th, after that flooding event, the vegetation just blooms. The second example for today will be from Bangladesh, from an area called Shamnagar, and we are going to use this area to showcase high-resolution imagery. Just like before, we will write our area of interest here, and then we will select the type of imagery, in this case, high resolution. After that, again, we'll have a list of the images available. In this case, they don't have a date, they have a time, because they all belong to February 7th. But if we go a little bit back, we will see a list of the available dates as well. Here you can see the footprint of the satellite images. The satellite flies on a strip, and they will take images just capturing photographs, right? Plum, 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 plum. So you can see how the path of the satellite comes by and how the images superimpose each other to ensure that there are no gaps between them. We will make a little square here to zoom into this area to better appreciate the high resolution imagery. You can see already this is high resolution. You can see that definitely the borders of features are more visible. Let's get rid of this overlay map with roads and names, and let's zoom a little bit more. And now you can definitely see what high resolution imagery allows you to see. In this area, we can clearly see the rice paddy fields, the borders, the different shapes and size of each of them, the houses, the roads and trails, even the individual trees. We can see as well the differences in color of the crops depending on the moment of the cycle that they are. It's truly a lot of information and a lot of resolution that we can take advantage of. This is how our medium resolution image will look versus the high resolution. Medium resolution 3.7 meter, still really good for landscape analysis, and we can still see structures, especially we use machine learning. Machine learning can detect features better than our human eye, and PlanetScope is used generally much more than SkySat for most studies, because for licenses reasons, most researchers use PlanetScope. But obviously, when you compare with the SkySat, yeah, the granularity and the degree of detail that you have is unparalleled. As well as with PlanetScope, you can also perform a spectral analysis with SkySat. I got this image a little bit changed in terms of contrast, just to appreciate better the roads and some features. And then we will perform a spectral analysis with the tools that we have on the right. Here you can see an infrared analysis that allows us to see identify really quickly water bodies. Here you can see different paddy fields that are flooded versus others that are not, and different water structures, as well as the trees and all different vegetation types. This will be the NDVI again, and as well very useful to see the different humidity availability in the vegetation. And this will be the NDYI, which also allows us to explore very well the water content and different vegetation types. Okay, so after that, because of the time, I'm going to proceed with some applications examples. If there is any question about the Explorer right now, pressing question, I'm happy to respond. Otherwise, we can take it at the end. Okay. I'm going to then proceed. There are many applications in the field of agriculture, impact evaluation, of course, climate-sensitive areas. I just chose 4 of them today because I wanted to make sure that we have enough time for questions and answers. But if anyone is interested, please feel welcome to email me, and I will be more than happy to mine publications on a specific topic. This first one was a beautiful study by Portinga et al. In 2021, where they used a UNet, a convolutional neural network, to map sugarcane in Thailand at large scale. On the right, you can see the sugarcane plantation in brownish. And the 4 images are just different type of unit models that they use, depending on whether they use RGB or some modified weighted RGB indices and infrared as well they use. They got results with over 85% accuracy, which is really good. And well, you can imagine the applications of this and the effects of this. Truly impressive. This other study by Walker et al. In 2022 was about detecting crop burning in India. Crop burning is a relevant human activity that needs to be monitored. It's very expensive to monitor on the field. And it happens at a small, medium scale. So this is done with PlanetScope, and they were able to use a random forest model and a linear regression model to detect these barn areas. And again, they got results with over 82% accuracy, which is promising and might allow to change the in-person monitoring for this remote sensing monitoring. This other work by Pierre Berre et al. In 2022 was about estimating groundnut yield in Malawi, and they also rely on PlanetScope, and they cross it with Sentinel-2 data. By the way, I like to add here that PlanetScope is compatible in terms of spectral bands with many spectral bands from Sentinel-2, which allows researchers to use the 2 of them together without much problems. In this case, they use as well a random forest model. And in the right, you can see the different model outcomes in different stages of the crop cycle. Seeding, yielding, I don't remember all of them, but again, they got an accurate, I think the margin of error of these models range from 1% to 11% error, which means accuracy near to 90%, which is, again, very impressive. All these studies that I'm showing, by the way, are published in peer-reviewed papers, and here you have the name of the publication, which, of course, you can check. I hope that we have the presentation available, and I will be happy to send the presentation as well. This last study is from our dear colleague, Professor Lino Estes from Clark University. He is leading truly groundbreaking work on using satellite data at large scale and using it in combination with different machine learning models. In this case, this was a really impressive study to try to map the field boundaries for smallholders farmers in the croplands in Ghana. And they were not only able to do it, but they got truly good results as well, with accuracies above 80%. Here you can see a probability map of the accuracy of the model, where the model was utilized. The areas that are yellow and green, where the model was used, represent the highest level of accuracy. And you can see smaller images here where the small farmers' crops are represented. This was a massive effort, especially because of the labeling. The labeling of these features was very time-consuming, but the latest development in automated labeling is making possible to replicate these studies and shorten the time in which you can develop and apply these models. So these are really exciting news. Okay, so with that, and yes, I'm happy that I'm on time. I finished the training session for the day, and I would like to have this time for questions and answers.
Hi, I have a question. Can you?
Hi.
Thanks so much for that presentation. Beautiful images and looks really exciting. So I had a question about images and wanted to get a sense of the spatial coverage and the extent to which researchers can say, hey, I would like images of these fields based on the sampling that's been done over time. Is that feasible at all? Or do the researchers have to sort of say, okay, here's what's available, and now I can do my research on it? So I appreciate you clarifying that. Thank you.
Thank you so much for the question. Yes, that's a really essential question in this case. For the medium resolution imagery, 3.7 meter, there is global coverage and daily images available. So you do not depend on what Planet has published because it had published the whole globe. Having said that, as I mentioned, there's a real issue with clouds. Say that you are interested in one area and you're expecting to have daily imagery available of this small area. And maybe you have 10 images available for 1 month instead of 30. That is because if the area is very cloudy, especially in the tropics, the image will be completely covered by clouds and therefore it will be not useful. But besides the clouds limitations, other than that, you should be able to have daily imagery of any point of the Earth. The images are published the day after. So if you were to go into the Explorer today, you can see images of September 11th. And it will go from September 11th, 2023 up to 2014. Although from 2014 to 2017, the quality of those images isn't as good. But yes, generally speaking, with medium resolution, you can access information for most places of the Earth. High resolution is very different. High resolution, because the satellites are tasked, they are sent over a specific location when a customer purchases an order, you will only have a fragmented cover of the Earth depending on past orders. Or you could buy the tasking and then send the satellite over your area of interest for a future date. So for the high resolution, it is not global coverage. It only covers what the customer targets, so to say, and it can target any area of the Earth. Again, clouds can be an issue that the team is gonna give you a threshold 15%, 1.5 of clouds, and they will not release or publish or give you back any image that is more cloudy than that. So medium resolution, global coverage, high resolution, customer defined coverage. That helps?
Yeah, thank you so much. And I forgot to introduce myself. I'm Tulika Narayan. Hi, everyone.
Thank you.
Hi, this is Dan Stein from ID Insight. One thing we've always felt is a barrier to using planet imagery is cost. I've also heard it's like kind of pricey. Can you talk a little bit about pricing and whether there's discounts available to nonprofits and researchers?
Mm-hmm. Thank you so much for your question. Well, first of all, I'm happy to say I do not belong to the sales department. I am nested in the science team, so I am not really allowed to talk pricing, which for me is...
You're the one we want to talk to, though, about this.
Yes, I know. But what I can tell you is that this last year, I know Planet released a special package for non-for-profits. My understanding is that if you're a non-for-profit, you can get the data at an extremely discounted rate. This started, I think, this year in March. This is very recent. I don't even know if people knows about this. And I will be very happy if you email me. I can contact you. I can put you in contact with the exact person that I know is not the salesperson, is the person who works for NGOs. And that is very discounted. And then the other side that I do work in is at the science side of Planet. The science program has different tiers of license. The first tier is free. There is a license called Basic User in the science program. I can actually show you all in a second, and that is free. The only caveat is that you need to have an affiliation with an university or a granting degree institution. So even if you work for a non-for-profit or an international organization or any other organization and you have an affiliation with an university, you can get this basic free account. The free account is limited in data. You cannot download as much data as other licenses, but you can go around with it. Then you also have two licenses that are free as well. One is funded by the Norwegian government. It's called NICFI. The Norwegian government pays for all the data on tropical forests in the world. And any researcher, activist, reporter, or any person who is interested in studying the tropical forest, particularly climate change or deforestation, get a free license through this program. Then we also have a NASA-funded program for researchers affiliated to NASA or National Science Foundation projects in the American region, unfortunately, only. And then we have the science licenses for universities that come at different packages, sort of, to speak. Let me show you the program. So there are ways for non-for-profits to get the data really, really discounted.
Rocio, you'll need to re-screen share.
Oh, sorry. You know what? I'm not gonna, I'm gonna just please send me an email and I send you all the links. Otherwise it will be very complicated to show all this. But yes, please, everyone should know that there are ways to get the data at very discounted prices, especially if you're non-for-profit or you have any science affiliation. And that's something that I encourage you to do, because indeed the price is a barrier.
Any other questions from anyone in the room?
I have a question. Hi, I'm Alice Laborte from Erie. The thing with using moderate resolution imagery and machine learning is we need a lot of ground observations. So using planet data, the very high resolution imagery, can we use that to collect data, and can we still reduce the amount of cost that we need for field work?
Yes, that's a great question. Thank you. Yes, in the studies that I showed you before with the sugarcane mapping or the small farmers mapping in Ghana, those are efforts precisely oriented to reduce the costs of having in-person visits. And you can definitely save a lot of money by using machine learning combination with satellite imagery. And you still will always need some ground data to train the model and verify the model. But I mentioned that there have been some late developments in labeling, which is the process of telling to the machine learning process, hey, this is a little crop. Hey, this is maize. This is rice. The process of training the model, you train them through labeling. And recently, there have been a few releases where labeling can be done also from satellite data, reducing even more the need for an in-person checking. I know that people like Lyndon Estes from Clark University is exploring this avenue to see whether it can be used across Africa. But again, I feel like there is gonna never be a substitution for having someone in the ground checking that what the model is predicting or the model is interpreting is right. But you can definitely lower the cost substantially.
Yes, I have a question. My name is David Ameya from International Center for Evaluation and Development. We have been exploring using Planet satellite for rapid data correction. My biggest concern is that working with smallholder farmers in Africa, you know, at times it's very difficult because the land size is not that large. And also most of them practice cropping. So my biggest concern is the resolution and our ability to be able to get a higher resolution that will help us to go through the crop cycle, you know, the planting season, the germination season, the growth and the harvest season. That have been our challenge. My question is, if we are able to select the area, you know, how possible are we going to be able to get a higher resolution that will help us to really do follow up with maybe phone interview or instead of going there personally to, you know, conduct the because we want to be able to do agile data collection without, you know, people going there. Our approach is to be able to do a profile, get the farmer's phone, be able to earmark their plots so that we can do phone interviews to, you know, collect follow-up data.
Thank you so much for your question. I think this is a really important conversation, and it also tells us that any study that is done with satellite imagery has to be very aware of how the field conditions are. In this case, very small farmers, small crops, diverse crops, and it has to be developed in combination with local communities and local stakeholders that know the area. Otherwise, it's not gonna be successful, no matter how good of a satellite imagery you have. You need to know your territory. You need to know your practices. You need to know your people. So I've read just a few days ago a new study that was done. Don't remember the area in Africa, forgive me. I'm gonna look again. But they were thinking about what you just mentioned. How do you differentiate the crop cycles using medium resolution? Because high resolution is more expensive, and high resolution, you don't have the same daily availability, the same cadence that you have with high resolution. So they were thinking, how can we use medium resolution to get an idea of the stage of these small crops? And someone local said, let's look at the piles, because after they harvest, they make small piles. Piles are very small. They are meters long. They are not big structures, but they can be detected with medium resolution. So they use medium resolution imagery to map the crop piles, and by that, they will know this farmer is already in this cycle. This other farmer is not. And there are always creative ways to find proxies and indicators. What should you look for on the ground? What can be an indicator of something? But for that, again, you really need to work with people on the ground and local stakeholders. I would say my preference is to try to maximize the value from medium resolution, because I feel it's more affordable, it's more abundant, and it's larger in scale, it's more replicable. If you, of course, if you can afford and you can make a sample with high resolution, that's great. But if you think creatively with medium resolution, you have many options, especially because when you use a machine learning model, the machine learning sees more than we do with our eyes. Because a pixel that for us look blurred, the model can detect this is a rice crop. And we cannot, but the model can. That's the reason why in the small farmers in Ghana study that I show, they could map the very, 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 very tiny borders of very, very, very small farms. With a human eye, if you see the image, you cannot do that. You cannot put a pencil and do that. But the machine learning has better capabilities to identify those tiny differences across pixels values. So I think there is still a lot of unlocked potential with medium resolution imagery to apply that scale. Thank you for your question.
Thank you.
I know that we are almost up to time, so I don't know, Carly, it's or Courtney, is this good, or do we have any
Is there
last questions?
any other questions in the room? I don't see any online, so if there's not any more, I think we will conclude right on time.
Okay, thank you so
Rocio.
very much. Thank you very much. Have a wonderful rest of the day. I'll see you again on Thursday. Bye-bye.